Not yet in 6 minutes. No, in 6 minutes I
I
start.
turned on the heating so you
Yeah.
could actually have it closed because you have that open. My throat is hurting. No, you can have it open if you close this door. You can have that.
No, it's okay. I have to see.
My throat is.
I still breathe, okay, so I'm okay. Because until your chest doesn't hurt when you breathe, it's not pneumonia.
No.
When you cough and when you breathe, if your chest is hurting and it's hard to breathe, that's pneumonia and that's the dangerous. Because that's when your lungs are infected.
After you check the link I sent you.
Oh, yeah, do I hear anything on this one? The chin is not on. You can see if you were on Mastodon or in the com chat rooms that similar like last time, there is also an additional feed just for the people who want to watch video and audio together, and the usual link for the people who just want to listen to this as a form of an audio only broadcast. Both of those links are in the links I left in Mastodon or in the com. It's very easy because the video one with the audio is twitch.tv/Victor Madaras, which is my name, and the audio only version is the one you're already using on anonradio.net. So, as I said, today's topic is going to be microservices, Docker, and Kubernetes part 1. I see 9 listeners online. That's already more than what I've expected. So let's see what we have here. We have to talk first about monolithic architecture versus microservices architecture. The microservices architecture separates the business logic functions, the core UI, and the data access layer, which then communicates to one shared or more than one databases. This is in contrast with the monolithic architecture, where it's built out as a tier 1 or a tiered layered approach, where the user interface, the business logic, and then the data access layer talks back to one big giant database, and it's a simpler flow of data back and forth from the user interface to the database and vice versa. While this is something interesting to look at, is because if you imagine your application, let's say you have a simple website which does a simple function. Let's say user can order something from your website through a user interface, which is the website, and it talks back to the database, and there are some business logic about user placing an order, and it's getting discounted from the database, and the necessary tables and rows are getting updated, and the user somehow pays for the item, the system requests for the shipping address and name, and everything is taken care of. In case of the monolithic architecture, this whole thing is built up in a form of a one giant piece of application, which includes everything from the user interface, from the whole logic mentioned, and a giant database altogether. Whereas if this same the example we used, website, is being built with the microservices architecture, then there is a possibility to break down the business logic part and the data access layers into separate smaller chunks or modules. They call them microservices, which is a perfect word for that, to be honest, which can each do separate and single functions of the whole big business logic previously mentioned. So let's say, for example, one microservice could take care of getting in the user's information, the name, the shipping address. Another module could take care of charging the user, taking care of the transaction part. Another module, microservice, could take care of updating the database when it comes to the stock and updating the stock in the database. If the user purchased 5 of the items, then 5 is going to be discounted from stock. And perhaps another microservice could take care of printing out the invoice or displaying or creating an invoice with all this information previously mentioned, the user's information, what he bought, the way he paid or how much he paid, and in a form of an invoice. Another microservice module could take care of that function. All these microservices could and able to communicate in between each other, share information. Each of them can have their own databases, as mentioned, or work towards one common database. And as you probably see, if you're looking at the video feed, or if you were just listening, that when you break things down to smaller pieces, microservices in this case, it definitely can have some advantages and of course disadvantages also. So let's see what advantages of using microservices can have. As we discussed how it compares to the monolithic architecture, it can be seen that, for example, one of the advantage is that it fits better or works more perfect for smaller teams, which can be assigned to a specific responsible function, microservice, or I would nearly say department, but a specific function of the big piece, the whole big piece of what your application is doing. For example, you could have a smaller 2-3 person team assigned only to the part of the microservice which takes care of updating the backend database about the stock when the user purchases something, to make sure that it's always showing items available only and if they are available. And another team could be taking care, let's say, only about the UI, the website, the front end the users are interacting with. And all these things can exist in between smaller teams. There is no need for one big team where everyone knows all the pieces and all the little nuances it goes into this big giant application in this example. And there is no need to have so much know-how or knowledge of every single individual in the team, because you broke it up to smaller pieces, so people could share responsibilities and have different functions assigned, and all together, the pieces together are the ones which fulfill the common goal of making your application work, and probably and hopefully the way you expect. Another good thing of microservices is that you can use any programming language for the purpose of that microservice you want to use, as long as a common API can be used on that programming language for communication between the microservices and also the UI. Most often this most common API used is HTTP. So as long as the programming language you chose for your microservice can use HTTP as a defined API for communicating, you should have no problem at all. Another thing which can be seen from this modular approach of the microservices being broken up to smaller modules is the certain kind of easier fault isolation. So if you using this website, we use this in the example, and the user gets as far as placing its order, and everything goes fine, the payment and everything. But when it comes to the last part, where let's say as part of a summary, the user is also presented with that invoice we mentioned, that let's say one of the microservices are responsible for that. Imagine that fails, or it doesn't display. Therefore, there is no need for that much of troubleshooting, because you would know that the problem probably originates from that piece of microservice. Of course, you have to see if it can access those information gathered from those different modules we mentioned. For example, the one which gets the user's data and shipping address, and the car details, and how much she paid, and what she bought. But if all those goes okay, and the invoice is not being displayed or not being displayed properly, then something is wrong with that piece of microservice. So you could get to the root, or to the bottom of the problem easier isolating where the fault is coming from. Another thing which it can help you with is kind of like a fault tolerance, not really fault tolerance, but like kind of. If you look at this previous example, that let's say the invoicing microservice dies, it will not bring down your whole application. It will be still pretty much 90% functional. So while it's being repaired in the backend, the site can continue, can get the orders in. The users will have some inconvenience not being able to show those invoices, but it's not the end of the world. On the other hand, if it happens with your application built in a monolithic architecture, you most probably end up with a site or with an application which will most probably not work, neither partially nor fully. So this kind of fake fault tolerance, because it's not really fault tolerance. It's just the thing that how lucky you are, that how much the microservice which fails is not part of the core of your application. If it's the UI, for example, then it's easy. The website is not displaying, so no matter that the rest of the microservices are up and running perfect, but in a lucky day, it can give you a bit less headaches. Also, microservices can sometimes being able to handle another microservices function or failure, in case of its failure, providing its function or replacing, providing again another kind of fault tolerance. They pair very well with containers architectures, microservices, because you can containerize a single microservice. They are dynamically scalable, both up and down, and with this feature, companies are able to save a lot of money, because in the era of cloud computing and on-demand pricing, or pricing of the instances are very expensive, and being able to dynamically scale your application or let's say in this website in a way that it uses less computing, less resource, when there is just let's say an average of 20 users per hour visiting your site, and maybe hardly any of them orders anything, compared to like a holiday season or a long weekend, when because of the shopping customs of people, you know that you could expect on those 3, 4, 5 days a much higher demand, a much higher workload for your site, and instead of the 20 you would have let's say 200 in per hour. Then with microservices architecture built from the ground up, your website in this example, as it works well with containerization, you can take advantage of dynamically being able to scale up and down, and you don't even need to worry about it, that let me remember to beef it up, because let's say Thanksgiving is coming and people will go crazy ordering something for that long weekend. It just can just take care of itself. So that's really the big advantage, and also the same advantage of that it can go the same way. It can downscale when required. So that's where the money saving comes in. So let's see the disadvantages of using microservices. There are not many, as far as you can see, the people who looking at the screen. One of them is, as you probably have guessed, complex networking. So while the monolithic architecture was kind of like a tiered, layered, simple from top to bottom application or flow, the microservices architecture, as it builds up from many as many as you want smaller microservices, perhaps each with their own databases or some of them perhaps sharing a database or working towards one common one, there can be all kind of relationship networking between one another. The module which takes in the user's information, like we mentioned in this example, for example, can share this information, talk to many other parts of the other microservices, the part where the payment happens, the part where the updating the stock database happens, the one which creates the invoice. So there is a complex web of sometimes confusing web of communication between these microservices, which can make troubleshooting not always the simplest, unless you are familiar with the design and the inner workflows of the application, or you just grew familiar with it because of the nature of your job. For example, I remember I have a colleague. He works in he's like application support engineer, and they pretty much support from top to bottom an application which much more complex than this one, but pretty much the inner workings are similar. The users interact with this application through a web portal, but in the backend it's like a crazy all kind of services and bits and pieces, and he really had to wrap his head around to really understand the complex workflow from start to finish, to be able to support this application. And this web portal they are running is part of language translation services. To have an idea, it's like a portal where clients and translators works together, and the raw text are being uploaded, and then it's broken up to pieces, and when the translator works on it, he puts the files he or she created, and then it goes into some ball and mixed up and down, and then file format converting, and it's crazy stuff and really complex. And like the ones who looking at my screen, brings us to the second disadvantage of microservices, of overheads. So the different servers and databases which has to be spinned up and down or needed to exist to assist to the whole functionality. Perhaps many smaller ones, or a couple of smaller ones, like you mentioned. You can use as many microservices and databases as you want to build up your application. So in the example of this colleague of mine in application support engineer, it's a very big complex networking and many servers as virtual machines and separate databases, and that pretty much looks like a web of complex thing of microservices, and it builds up to a very complex application. So as mentioned, it can be counted as a disadvantage, the thing that it requires extra knowledge and familiarity of the topic, of a few topics, like the architecture, the way how the whole thing is built up, containerization on its own, container orchestration, for example, Kubernetes would be one of them, and the knowledge overhead, as I mentioned. Apart from that, databases and servers, the extra bits and pieces which you need to spin up and down. I see we have 5 minutes left. I was talking quite slow today, it seems like. Oh, and a lot of people were talking in the chat. Chat. What they say? Oh, they don't say anything for me. They go playing Dope Wars. Okay. Well, they came back from playing Dope Wars. So, I think for part 2, because I don't know if in 5 minutes I could talk to you about Docker. Well, we can talk about Docker a little bit. So we talked about microservices compared to monolithic architecture. About Docker, we talked about in the episode we did on virtualization, episode 14 and 15. We know that Docker is a type 2 virtualization in a form of a platform as a service, which delivers software in packages called containers, and it's using OS level virtualization as we discussed it. To put Docker in simpler terms of explanation, it is an application. Docker is an application build and deployment tool. It is based on the idea of that you can package your code with dependencies into a deployable unit called a container. Containers have been around for quite some time, and I found this on when I was researching Docker and containers in general. On some website it mentioned that there are some people who say that containers were developed by Sun Microsystems and released as part of Solaris 10 in 2005 as the Solaris zones. But some other people mentions or stating that it was BSD jails were the first container, so to say, technologies. I put this in here because I have great respect for both Sun Microsystems and Solaris, and also, as I mentioned in the previous episode in Unix, BSDs, which I mentioned that for me, the most Unix-like operating systems still available today, when we were talking about Linux and BSD and some other. For me, it's BSD, which are I think I mentioned or I expressed it as like the most Unix truest to the root of the original Unix. BSDs are for me the ones, if someone understood what I was trying to say just now. So that's why I copy pasted into the show notes this piece, because it was nice to read that. Nice to read and nice to remember that not everything is which they come up from one day to another. Is not everything new under the sun. As we discussed in the episode of virtualization, many things regarding virtualization. I remember I mentioned it was going back to the, I think I'm not mistaken, in the 60s or 65, and the mainframes were also involved in the history of virtualization. So many things are not invented from nothing, but built on existing ideas or technologies, and they just perhaps reshape it or sometimes even just give them another name or another color, and sometimes they try to sell us as a new and biggest invention. But for example, another oh, the time is up. Time is up. So, the people who were listening to me in the broadcast, the audio broadcast, they already lost me. But you see, this happens when I try to talk about Docker and some other things quickly in 5-4 minutes. And yes, the guys are making me remember that the clock is a harsh mistress, means that the live stream is cutting off exactly at 6:30 UPC time. But that's why the people who listen to this in a form of a podcast and download it, they can have this extra bit and piece of information. Normally I don't run overtime, but now this happened. It means that you didn't lose the last bits and pieces. I will continue from next week where I was cut off, which was probably when I started to talk about the Solaris and the BSDJS note I found when I was investigating this thing. So thank you for everyone for listening, and see you next Saturday for part 2.